Hello, it's Mr. Cerisa, and today we'll talk about vectors in space. And this just means three dimensions. So we have the height and the length, but we also have the axis going towards and away from us. So there'll be three axes. And here are our objectives. If you want to pause, you can find out. But most of this will be very similar to things you have done before. Here is the rectangular coordinates for in space, and you can see that we have the x, the y, and the z axes. And the x is the one that comes towards you and away from you, the y goes left, right, and the z goes up, down. So a lot of times this is really confusing and difficult to picture. What I would do is just look around in the room that you're sitting in, and this is the corner of the floor that's in front of you and away. The negative you obviously can't see, but if you are in a room, this would be in the next room going away from you. This would be the room off to the left of you, and down here would be the basement. So again, it's really hard to visualize this. So what I would suggest if you're having difficulties is maybe getting just a small box, like an empty tissue box, and having that as working towards your coordinate plane, and just pick one of the bottom corners to be your origin. Alright, so we use the right hand rule in order to do this. So the finger points towards you. That is the x-axis. The thumb points up as the y-axis, and all the other fingers point left, right for the y-axis. And then here's like the example that I kind of mentioned with the tissue box. If you want to do that, have it in the corner. And then so first you have 2, so you go out 2. 1, 2, and then go over to the right 3 to get to this point. 1, 2, 3. And so notice it doesn't line up with the points on the y-axis, but if you just space it evenly like it is on the y-axis, then you can see how it goes along. And then same thing with the z-axis. If you're going up 4, and then here you go is that point 2, 3, 4. So it takes a lot of practice doing this. But when you're doing it and you can picture it in your head at the same time, it's really helpful. Alright, and then just here's a little bit more, because you're thinking just points, but there are also planes. And the planes can be described like this. If you have an x equals 0, that's the yz plane. Very similar to the y equals 0 on the regular Cartesian plane. The y equals 0 is the x-axis, and the y-axis is x equals 0. Same thing happening here, and then you could have the plane z equals 3. That's just all the points where z equals 3, and z can't equal anything else, so that's why it becomes a plane. Alright, next we'll go over some different things that you've done in this 2 dimensions, but now you'll do in 3 dimensions. Alright, thank you.